Greetings folks and welcome to the Electromaker podcast. This is the audio version of a midweek roundup of maker news and embedded projects that I make on YouTube for Electromaker. Now this week's show is slightly different just because I had a series of internet outages and had to kind of grab whatever footage I could to narrate for the show. And it actually resulted in quite a nice show because there's a lot of smaller projects I wanted to talk about and I was able to cover quite a lot of ground. We have maker projects directly from our Discord server, everything from internet controlled first-person video Roomba control to making the tiniest violin using a thermal sensor, and Mellow Labs completely hacking his washing machine to be able to put in detergent without having to actually pour detergent into it. You just press a button. It's a really nice build. We also feature development boards, one of which is from Carl Bugeja, who has come up with an ESP32 C3 development board that is somehow smaller than the ESP32 C3 Seed Studio Zhao, but with more features packed into it. We also look at a $15 board from Maker Diary with an ARM Cortex M7 in it that is clocked at 500 megahertz, which, yes, you can program the hard way, or you can program it the arguably better but still very hard way with Zephyr, but you can program it with CircuitPython as well. And it's the closest thing to the Teensy 4 I've seen since, well, kind of the Teensy 4, basically. So, with all of that to get through, we should get on with the show rather quickly, but before we do, just one quick reminder that there are no sponsors on this podcast, no advertisements, anything like that. If you do want to support us, head to electromaker.io/shop, where we stock pretty much everything from everyone. If you're looking for an Arduino or Raspberry Pi product, we have a huge amount of those in stock. We also stock things from Adafruit, Sparkfun, and companies like Nordic and NXP. So pretty much whatever you're looking for, if you check with us, that will help us out financially and directly. And with all of that out of the way, let's get on with this week's show. We're going to start this week's show by looking at Mellow Labs, specifically his most recent video about a DIY detergent dispenser for his washing machine. But before we get into that, the Mellow Labs YouTube channel is a real gem, and if you're not already subscribed, head over and give Thomas a subscription. I think I just pronounced your name in a very German way, Thomas. Thomas? I apologize. But yes, he's one of those makers that looks at the world around him and says, how can I hack this using the tools I know, or maybe some stuff I don't know and I need to learn in order to make it A, better, or B, funny, or C, both, and get educational and entertaining videos out of it, which he succeeds in doing almost every time. Almost every time? Well, which video of his do I not like? No, every time. What am I saying? I could already tell this week's video is going to be a bit of a struggle. Anyway, onto the build. Now, I am going to keep this rather brief, although I would like to point out that Thomas is wearing a really quite wonderful t-shirt. Fantastic choice of fashion there. So, what do you need to do to make a washing machine a little bit more automated? Well, the water already comes out of the wall. What if you could just have a refillable big bottle of detergent that pumps the detergent directly in the right amounts into the detergent tray? That's essentially what this project is. But the thing about Mellow Labs videos is that he goes through the original idea, talks about things he's tried before, and goes through the process with you, what works, what doesn't, and does some testing to see which is the right kind of pump as well. The original idea was to have it pumped directly into the tray and have it housed inside the washing machine using the power supply of the washing machine. And he does manage to do that with one slight caveat. He decides halfway through, instead of making it your more typical smart home connected device that you could actually set going via Wi-Fi, to simply use a Raspberry Pi Pico and put a control on the front of the washing machine using a rotary encoder in order to put the right amount of detergent in it, or to get a warning when the detergent is empty. Now, this video also includes one of just my favorite things to do with kind of maker hacky stuff, which is opening up an already existing consumer device and seeing how you can put your own electronics inside it and how well you can make it play nice with it. So there's obviously a bit of space inside this washing machine, but you want to be able to do some kind of sensing as well of what is going on with the washing machine in order to put detergent in at the right time and in the right amounts. Now, Mellow, I'm going to call you Mellow from now on, I suppose. Thomas goes through a number of options of what you could use. For example, the lock on the door would be a good signifier, or the LED from the lock on the door. And that iteration is a process that is definitely worth seeing. Another nice aspect is the pump test. Thomas has various different pumps that he decides to test, and does so, testing how long it takes for the fluids to go through each one, pointing out good and bad points between them and the different voltages they use. So I'm pretty much going to leave it there. I know this was a very quick whip through, but as always, I'd like you to go to the actual project video itself and watch it, give them a subscription, leave a comment and say how much you like it. If you want to leave a comment, say, hey, I saw this on Electromaker, of course that would be great for us, but it's not necessary by any means. Yeah, it's just a really nice compact build that fits perfectly into the washing machine, uses its power supply, and has this little rotary encoder on the front for how much you want to put in. That gives you a gives you a visual feedback when the detergent is empty and you need to refill the bottle at the back. The link to this project will of course be under this video. Now, the creators of the next two projects, along with Mellow Labs, are all members of our small but friendly Discord server, and if you would like to join it, there is a link to it in the description of this video. We have multiple rooms, rooms where you can show off your products, rooms where you can suggest things that would be good for the Electromaker Show, and also places to just generally hang out and ask questions. And there's a nice mix of people of different levels on there. There's people on there who are like proper engineers who understand things on a level that I never will. There's people on there who are just getting started as well. It's a very friendly and welcoming place. It is also the place where I saw this video from Aesthetic, who recreated Mr. Krabs' tiniest violin. Now, I'm playing it with the sound off here, but this is a very famous SpongeBob clip, and Mr. Krabs is playing the tiniest violin between his claws, and it actually exists. It is a truly tiny violin. But Aesthetic decided to actually create this using a sensor to check when his fingers were playing the tiny, tiny violin and create an actual playable tiny violin. So the build uses a thermal sensor in order to detect when the fingers are playing the tiny, tiny violin. And there is a separate short video that goes through getting this thing up and running. But I want to show you two very short clips from the main video, which I am sure will convince you that this video is worth watching and Aesthetic is someone worth following, because they definitely fit the mold of a maker who also makes wonderful and entertaining videos. So first, a quick demonstration of the finished project. So what you're seeing there is the mechanism for playing the sound. You rub your fingers above the thermal sensor and it will play the sound from a WAV player SD card. However, the only other thing I wanted to show you, a very brief part of, is the build process, because the montage that Aesthetic has created for this is just wonderful.
3, 2, 1, go!
So yes, hopefully that gives you a bit of a taste as to why I find this so wonderful. Everything you saw in that final shot there was created by the maker. The case is laser cut out of wood and then stained. It has a little actual brass plaque on it saying what it is, and all the electronics, as you see, were actually modeled in Blender before being created so that they would fit perfectly into the case. It is a very thorough project and one that I think you will enjoy. This is Ollie Q, talking about how much Roombas are not as smart as they should be, and making the argument that wouldn't it be better if you could just drive a Roomba yourself? Or wouldn't it be even better if you could get other people to drive your Roomba for you over the internet and make a game out of it so they would clean your house for you? And then he did it. But how? Well, step one, hack a Roomba so that it will do what you want it to, or in this particular case, not quite what he wants it to do yet. Step 2, try to set up streaming low latency video over the internet yourself. Yeah, this is accurate. Brief sidestep for one of the coolest little distraction tangents I've ever seen. That's him using a full racing wheel setup to control a Roomba in the room with him, with the live video feed going to his laptop in front of him, which is amazing. Fast forward to opening up this Roomba to his community, because he has quite a large following on TikTok who try to clean his flat for him. Now, Ollie wanted to find something out. Could the Roomba clean the flat using its own internal AI, or whatever is in there, better than his actual audience? Well, I will leave that to you to find out. This is another one that you don't want to miss. Ollie is someone who deserves far more subscribers on YouTube than he does. Another person who makes wonderful projects with wonderfully made videos. Do head over to his channel and subscribe. Link in the description. We're going to move on to Hagiwo, who is a YouTuber from Japan who's been creating modular Eurorack synthesizer parts out of Arduinos and other similarly low-powered microcontroller boards for a long time. This is one of those channels where I've been following them for quite some time, and it's a real struggle to not put almost every update they put into the show, because they're all just so inventive. They're not necessarily doing anything new. They're doing something that is quite difficult and quite expensive with incredibly cheap parts. So yeah, his videos range back for about 4 years at this point. It is a wonderful deep dive YouTube channel if you are interested in building up your own synthesizer in that modular style on a budget. But his latest video was interesting for me on a couple of counts. But I think we'll start by just letting the opening of the video play so you can hear what we're talking about. So as you can see, we have the Seed Studio Xiao RA4M1. This is using the same Renesas microcontroller you find in the new Arduino Uno R4 Wi-Fi and Minima. And it is a very powerful 5-volt tolerant chip that's still quite cheap, and it has a 12-bit DAC on board, making it perfect for outputting digital audio in 12 bits. And the module is fully featured. You're seeing on the side here, one of the knobs here is for frequency, that's the pitch of the note, and the other one is for changing the wave shape. And as you can see on the oscilloscope here, it is changing. The two outputs here, one is for audio out and the other is for CV in the 0 to 5 volt range. And the built-in 12-bit DAC is going to sound pretty good. And some people get a little bit funny about different qualities of DACs. And yes, if you really want to get down to precision, you do have to think about that. But I would like to point out to you that beloved samplers like the Volca Sample 2, yes, this is a very cheap unit, it's not perfect, it's definitely a bit older right now, combine things in a rather beautiful way. This has a 12-bit DAC combined with an analog output for different sounds. It has an EQ on it, which is a little bit more than an EQ, really. And this thing sounds like nothing else I have ever owned, even though it is limited. If you're looking for a little sampler that has a bit of a learning curve, but you can get very cheap secondhand these days, Volca Sample, recommendation. Anyway, that was a little bit of a tangent. If you would like to find out more about the project, the video goes through a lot of the details of it. There is also under here a note which has the working documents for this. Note.com is where Hagiwo puts all of the stuff. There's a whole repository of all of them on notes.com that you can find a huge amount of information about. It's all in Japanese, but of course you can translate it. For this particular project, you can find the page under the video. It has the video here, and further down is a code example, which is all in easy to understand Arduino IDE code. So Hagiwo is another channel that I highly recommend subscribing to. I've been following them for years, and they always put out really wonderful, really low budget builds for those who are inclined to work with microcontrollers and music. So me. I'd like to take a moment to say a quick thank you to everyone who has taken the time to subscribe to our channel over the last little while. To my estimations, we've gone from 10,000 to 20,000 subscribers in what feels like a very small amount of time, given the kind of thing that we make. So thank you to all of you who keep coming back to this channel, and thank you to all of the new arrivals. For those of you who may just be getting here, if you do enjoy the show and you do enjoy the kind of content we're making, do subscribe to the Electromaker YouTube channel. It does make a big difference to pointing us to other people who may be interested in it. Also, if you like the video that you're watching and set up notifications, leave comments on the video, all of that kind of stuff is very appreciated, but of course not necessary. This show will be here for you regardless. However, if all of the YouTube stuff doesn't really appeal to you, but you still want to support us in a slightly more concrete way, Electromaker has a shop that stocks things from pretty much everybody. Raspberry Pi, Arduino, we stock everything from Adafruit and Sparkfun, for example, Nordic Semiconductor, NXP, a huge amount of companies, and a huge amount of things. Like, for example, I was talking just before about the thermal sensor that made the Mr. Krabs Tiniest Violin box work. If you want to get one of those for your own projects, we do sell a breakout board for that exact thing in the shop as well. It is, of course, not necessary, but if you do decide to spend your money with Electromaker, that helps me continue to do this show, as we do not fund our show using YouTube adverts or anything like that. Same with the podcast. It's just something that we're doing we're funding ourselves with the shop. So yes, if you do want to get anything for your next project, do consider getting it from Electromaker. But for now, let's get on with the rest of this show. We're going to move over to Carl Bulgasia, whose name I may have mispronounced every time I've said it. Apologies if that is the case, Carl. He has created one of the smallest ESP32 C3 development boards I've ever seen that packs a huge amount of utility into it. It comes with a 9-axis sensor fusion IMU on board, along with light sensing and battery charging, USB-C programming, and a dedicated Arduino library designed to make it easy to use, which is a lot to fit into one board, and what I believe may be his first development board, or at least his first commercial one that he is selling. Now, I will of course be linking the video in the description. It's only 8.5 minutes long, and I would highly recommend going and watching it. There is a reason why his YouTube channel has over 250,000 subscribers. He makes very good videos about the kind of things that we are interested in. But I'd also suggest going and taking a look at the website as well. Because not only can you buy this directly from the Microbots website, of which Carl is a part of, it also gives you more of an idea as to what we're talking about here. So as I previously mentioned, it has the 9-axis IMU on it. It also has a light sensor, and it is USB-C programmable. As I mentioned, that's where the battery can plug into it. But as I previously said, there is a full Arduino library specifically for it and a bunch of different examples. So let's say you wanted to look into the remote example. This gives you a full tutorial as to how to go through it and all the examples sample code you need. And as previously mentioned, they have their own code cell library that they've created for the Arduino IDE. And presumably, of course, you could program this any other way that you wanted to if you prefer to use Platform IO or however you're programming your Arduino type boards these days. So if you would like to get a hold of one of these, they're available directly from the Code Cell website. And I have stood on this show on my little soapbox many times before and said that things cost more when you get them from people who are creating them themselves. It is no easy feat to get a product out the door at all. And it is a completely different game to producing things in the tens of thousands and buying them as clone boards off AliExpress than making something yourself and making a bespoke library for it and good documentation. I'm not saying that there aren't boards that are really cheap that have libraries and good documentation at all, anything like that, but it is just different from a business perspective. That said, I was wanting to get my hands on one of these immediately as soon as I saw the video, and I found for me personally the cost of getting one with the full biscuits, all the beans, light in motion with the battery and with soldered headers and all that kind of stuff. The cost of $36.49 was absolutely fine, not a problem. I'm absolutely willing to pay that for something of this quality and to support someone who's doing it like that. However, the cost of sending that to me here in Germany was astronomical. I think my wallet that I would have had to pay towards the end was more than twice the cost of the board itself. And this is actually because of something I've run into personally as a problem sending prizes on the Electromaker Show. In the past, when I've had to send lithium batteries to the post, it's been a nightmare. And we've had to jump through all kinds of hoops, and Carl has obviously had this problem as well. In the YouTube comments of the video, he mentions that he has to send it with a certain kind of box in order to get it to actually be sent, and presumably that's just within America. I'm not absolutely certain. I don't actually know where he's based. But the point is, if you would like to support this project, maybe consider just taking the battery out of the equation, finding your own battery locally, and of course you don't necessarily need soldered headers, although they are quite nice, which will bring the cost down a little bit and should bring your shipping costs down as well. Anyway, as I initially said at the start of this, check out the video. It will go through it in a lot more detail than I am able to, although I probably spent as much time on my soapbox as it would have taken for me to explain it in detail. I'm aware of that. And it also gives you some wonderful examples of what this board can do. If you are interested in finding out more, the link to this video will be in the description. Now, a few months ago, we were at the Embedded World conference here in Germany, in Nuremberg, and there was a lot of wonderful stuff. This is the roundup video from there. Raspberry Pi did something quite interesting that time, in that they brought some new things with them, but they didn't announce them. These weren't things that had been talked about publicly at all. They were just sort of there. So they had their own display there, that was one thing. And the other is this AI camera attached to a Raspberry Pi Zero, you can see here. And the AI camera module itself is now available. So it was quite an impressive thing. It was doing person detection on the edge in real time. You can see me waffling to the camera there, being filmed talking about it. The camera itself is now available. The camera unit is available from $70, and it uses the Sony IMX500 intelligent vision sensor, something I know nothing about, but will probably learn a little more about when I get a hold of one of these. I own one edge camera sensor, and I have forgotten the name of it. I got it as part of a fundraiser a long time ago, and fiddled around with it. It does its job wonderfully, but I'm kind of looking into learning a little bit more about it, and so I will be getting one of these, so I'll talk about it more then. But at this point, I feel most people are somewhat familiar with the concept of what an AI camera does. It is a camera module that has a certain level of edge AI capabilities on board, which takes the burden off your host microcontroller or single board computer. So I'll leave a link to the page from Raspberry Pi in the description of the video, where you can find everything else you need to find about it. I will be coming back to this one personally later, and we'll talk about it more then and at more length, and when I have a functioning nose. And if you would like to see this video of the roundup of Embedded World, I'll leave a link to it in the description. You can jump to the part with the Raspberry Pi camera just down here. If you click on the number here, it's actually just a few seconds off. It's like 10 seconds into the future, but you can click. All of our videos have these timestamps on them in case you're not familiar, and you can jump to anywhere you want in the videos using those. Finally, on this week's show, we're going to look at a $15 development board from a company called Maker Diary, and I find it interesting for a number of reasons. Firstly, it is a microcontroller development board featuring the IMX RT1011. This is from NXP, and it is one of their crossover MCU series. But it is, as I mentioned, only $15. And yes, you can run Zephyr RTOS on it if you want to go down that route, and of course, I am very interested in that, but it also comes with just a plain UF2 bootloader if you want to get pre-made firmware and flash it, and also a CircuitPython interpreter bootloader, which allows you to run CircuitPython on the board in a very similar way that you would, say, a Raspberry Pi Pico or something like that. The difference comes from the fact that this is one of NXP's Cortex M7 chips. Yes, Cortex M7 chips running at 500 megahertz, if I remember correctly, which is an incredible speed. In fact, the only development board I can think of that is running at about that speed, clocked at 500 megahertz. The only other sort of more maker-friendly board I can think of that's clocked about that fast is the Teensy 4. And of course, Paul, who's behind Teensy, took that idea. I think it may even be one of the IMX crossover chips on that board, but he's taken all of the hard engineering side of things, which is still way above me, and then put it into the context of libraries that are easy to use and easy to get started with. In that case, things like the Teensy audio library or the Teensy tool, or all of the stuff that you can do with it via Arduino. In this particular case, it's very similar, but the addition of CircuitPython is something that I think will make this a lot more accessible to a lot more people. Now, if you want to see the full rundown of it, I can't recommend the CNX software article enough. It tells you everything that you need to know, including where you can get your hands on one, which is also one of the other reasons why I wanted to share it with you, so I could share the possibility that you might buy one of these out of hand, just because it looks interesting, because that's exactly what I did when I saw this. I saw it and thought, oh, that's really quite interesting. A very powerful development board that's very well documented, that I can program in multiple ways and use as one of the things I keep in my laptop case when I've got a train journey and I want to do a little bit more learning more about Zephyr, for example. And if you wanted to set up to work with Zephyr, all you need to do is head to the Maker Diary GitHub, where it has a full description of everything you need to know, including different instructions for setting it up in different ways. So this is how you set it up for using a UFT bootloader, for example. Or if you want to set it up in Zephyr, this is setting up the Zephyr environment, and then there's building and running samples, and it's all very much in the same style and language as the official tutorials on the Zephyr project. But again, Zephyr is incredibly complicated, and that's something that I plan to learn for the rest of my life just for fun. But if I wanted to do something with this board today, I'd probably reach for CircuitPython. And getting started with CircuitPython is very simple. Once you have the UF2 bootloader present, you need to follow this tutorial first, you can run CircuitPython in it like you would in any other way, and code with Moo, which is something that I think some people will be quite familiar with. Moo and Thunny are sort of interchangeable in my mind, as they are both very easy to use code editors that are perfect for working with Micro and CircuitPython. If you are interested in finding out more and maybe grabbing one of these for yourself, the CNX software article is the place to go. It will be what I will link under this video. Once you've read it, at the bottom here, there are links to the wiki page, which has all of the getting started guides I mentioned, and the GitHub page too. And there's links to the official Maker Diary store and the Tindy store. And after my rant earlier in the show about the cost of things, I have to also point out that this board, which does appear to have basic but fairly decent documentation and various ways of working with it, was only $21 shipped. So you can make of that what you will, and my attitude towards things when I get on my little soapbox what you will. But yes, I'm very much looking forward to getting a hold of one of these, having a play with it, and seeing what I can come up with. Because it's not every day that such a powerful microcontroller comes along that has so many different ways of working with it. I'm very much looking forward to getting CircuitPython up and running and just dimming an LED, and then trying to do exactly the same thing in Zephyr OS for the next month. That was the show for this week. Thank you so much for joining me. Thank you for your patience with my slightly strange sounding voice. I may not have mentioned this in the introduction, but I had quite a thick cold throughout the process of trying to put this episode together, and as you can hear, it is still there. So I hope that didn't put you off too much. We'll be back next week with a regular show, hopefully with me sounding completely healed and back to normal. But until then, I hope you have a safe, fun and creative week, and I will chat to you soon.